What's up, Chem peeps? Let's do one more practice problem with excess and limiting reactants and ice tables. The black oxide of iron, Fe3O4, occurs in nature as the mineral magnetite. This substance can also be made in the laboratory by the reaction between red-hot iron and steam according to the following balanced equation. Boom! Three things. When 36.0 grams of H2O is mixed with 167 grams of Fe, which is the limiting reactant. What mass in grams of black iron oxide is produced? What mass in grams of excess reactant remains when the reaction is complete? Alright, my first step, I'm going to copy the equation down and set up my ice table. Boom! My first step is to put in the initial number of moles of everything in the reaction. I've got 36.0 grams of H2O. Be careful! You only want to include moles in your ice table. So before I begin, I need to convert this number of grams of water to moles. And I'll do that using the following dimensional analysis. 36 times 1, enter, divided by 18.016, enter. To 3 sig figs, I get 2.00 moles water. Note that I'm also given mass in grams of my other reactant iron. So I'm also going to set up a dimensional analysis to convert that to moles. Boom. 167 divided by 55.85. To 3 sig figs, 2.99 moles of iron. Alright, now that I have number of moles of each of my reactants, I'm going to plug that into my ice table. Boom. Remember that my initial number of moles of each of my products will each be 0. Alright, so a little extra step to this one. Remember, it's important that you only include moles in your ice table calculations. Next, let's determine the change by choosing one of our reactants as the limiting reactant. I'm going to start with iron. I'm going to assume that this is my limiting reactant and it's completely used up, which means that this will decrease by a value of 2.99. Next, I have to determine the change in number of moles of water. Come back to the stoichiometry. How does the number 4 compare to the number 3? How does the number 4 compare to the number 3? It's 1 1/3 times as big. So if this decreases by 2.99, this is going to decrease by 1 1/3 times as much, or 3.99 moles. Now I'm going to stop here because I can already tell I've chosen the wrong reactant as my limiting reactant. It would give me a negative number of moles of water at the end. So let's reset. My limiting reactant is water. That means all 2 moles get used up. Let's determine the stoichiometric change of iron compared to water. How does 3 compare to 4? It's 3/4 or 0.75 the amount. So what's 3/4 of 2? 1.5. So this will decrease by 1.50 moles. Next, compare Fe3O4. 1 to 4, 1/4. Or 0.50 moles will form. It'll be positive because 0.5 is 1/4 of 2. And then finally, our hydrogen will increase by 2 moles because how does 4 compare to 4? It's the same. So however many moles of water is consumed is going to equal the number of moles of hydrogen produced. Alright, final step. Let's determine the n number of moles of each of these things. I'm going to have 1.49 moles of iron, 0 moles of water, my limiting reactant, 0.5 moles of Fe3O4, my magnetite, and 2 moles of hydrogen. Let's answer these questions. Our limiting reactant is going to be H2O. Boom. What mass in grams of black iron oxide is produced? Oh man. We only found number of moles. So I'm just going to take my number of moles of black iron oxide and convert it to grams. Boom! Quick jump to the calculator. 0.5 times 231.55. Enter. That's going to give me 116 grams of magnetite. 116 grams magnetite. Finally, what mass in grams of excess reactant remains when the reaction is complete? Again, be cautious. Your ice table is giving you number of moles, so you're going to take your number of moles of excess iron and convert to grams. Boom. Quick jump to the calculator. 1.49 times 5.85. Enter. We're going to have 83.2 grams of our excess iron remaining. So, just another example of an ice table calculation for excess and limiting reactants. Just be cautious, you only want to include moles in your ice table. Have a fantastic day.